So welcome back. In this lesson, we are actually going to make the actual grid of image views. So let's see what we're gonna need to do for that. I'm gonna write down some comments. This is at the end of the onCreate method. Let's go and make a private. I'm gonna call this one TileMaker method. All right, and what's this problem? Private void, of course. And then let's call TileMaker. So this is TileMaker method. So we are going to do everything within this method, and we're just going to call it at the end of the onCreate for now, but later we will change this as well. So let's see how we want to make our tiles. I'm going to write some comments so it becomes a bit easier for me to explain and for you to understand as well. So we first need to know the size of the grid, know the width and height of each tile, know where to place each tile in the grid layout, and that is no. And also we need to know which image to display on it. So that's pretty much what we have to do. Okay, the size of the grid, we already know it, and that is the grid size. We have it up here. It's called grid size. For now it is 4x4. Later on in these two actions we're gonna change them. You don't need to do this, but so that we know grid size in a 4 is gonna stay 4, but in a 6 grid size is going to be 6, and then we're gonna do something else. So I'll come back to this in a few lessons, so don't worry about that for now. Now we then need to understand the width and height of each single tile, and that's actually quite easy. So it's integer. Let's call it tile width, okay? Because I don't need to make width and height. Width and height, they're equal to each other. So it's basically, as long as we know one of them, we know both of them. I'm gonna say that is equal to the value that we called screen width. So screen width divided by grid size. So if my screen is whatever size and I'm playing in a 4x4 mode, I divide that by 4, and that becomes the width of each square that is going to be one of the image views. So we found that part. We then need to know where we place each tile, and that's something I'm going to come back to. That's basically a part of the grid layout that we have to make, the layout in which we place our new objects or new image views. So that's something we have to come back to. And then the next thing that we want to make is understanding what image to display on it. And I'm going to go ahead and say, to know what image you want to display, a string I'm going to call image name, and that's going to be the name of the image we will be showing, but it's not currently assigned to any value, simply because for each of the tiles we have to give it a different name. So let's go ahead and start building our image views. Let's try and imagine that once we run our application and the simulator loads, we should give it a second for the simulator to load apparently. Okay, So let's try and imagine that I want to do this. Okay, I know that this area is, and the width is, let's say 412. All right, let's say 400, and let's say 400. It doesn't matter. This is just a test. Okay, so I have to say one image of 100 by 100 more or less has to be here, then another one has to be next to it, then another one has to be next to it, so on and so forth. And then I have to make the next row, and the next row. So I have to make one row of 4 of them in here, then another row of 4 of them in here, so on and so forth. So with that in mind, I'm gonna say int for integer of v equals 0, v smaller than grid size, v plus plus. So for the moment, because grid size is 4, it's going to be 0, 1, 2, 3. All right, because we know that. So for that, I'm going to say image view. I'm going to call it img view or img tile. All right, that's a better name, img tile. It's a new image view within this activity. So we make a new image view. Now the next thing that we need to do is, we said we need to find where we're gonna place this object, and that's something that we have to figure out. So I'm gonna go ahead and say within the grid layout dot spec dot row, let's call it, what was the name? Row. I'm going to call it row spec, so it's easier for me to remember. Grid layout invoke spec, and I'm going to say the spec that we want to use for the row is 0, because we are currently only on one row of images. Remember, we are trying to make this one and this one and this one and the last one. So the row is always 0. Then I'm gonna say grid layout dot spec, and this is gonna be called column spec, for instance, is a grid layout dot invoke spec, and this one I'm going to call it based on the v. So whatever is the value of v, that value is the value that the columns get. So basically 0, 1, 2, and finally the third one. All right, so we got that part taken care of. The next thing we want to do, we want to make the layout parameters for our image view. So grid layout dot layout parameters, this is called tile parameters, is a new grid layout dot layout parameters, and layout parameters can be initialized by context, parameters, margin, sources, row spec, and column spec, exactly what we built. So I'm gonna say row spec and column spec. So basically I'm saying the parameters for this upcoming tile against the grid layout that is gonna be its parent is under row 0, and for the column that we are on it. One more time, the parameters for the tile that we are about to make, that is the image view, the parameters for that against the grid layout that it will be sitting inside, and that would be its parent, is row 0 and column based on where we are in the for loop. So row 0, 0, 0 and 1, 0 and 2, 0 and 3. So that's actually very very convenient and excellent. Next thing, I'm gonna say tile parameters dot width is gonna be the size of my tile, and that is tile width. That's actually very easy. And I'm gonna say tile parameters dot height. That is also gonna be tile width, because we said the width and height are identical. So far we got this far. I could go on and add the image that we want to display, and we still have to do something else about here, but let's just simplify our process for now. I'm only going to go ahead and say img tile dot set background color dot red. That's just so that I can see it vividly and I can decide if it is doing what I expect it to do or not. And finally, I'm going to go ahead and say img tile dot layout parameters are the tile parameters. And finally, I'm going to say game grid layout dot add view, and we add the img tile. Let me run this application once, make sure it is working, then I'll come back to you and explain what we have done so far one more time. Let's run again. And we are here in the simulator or an emulator, whatever it is called. Great. So now these are four image views sitting next to each other, which is exactly what we wanted to see in here. Let's come back here and revisit this situation. We're calling the tile maker method. That is a private method here. In this method, we do a few things. We say for 0 to 4, make a new image view, and for that image view, give it layout parameters for the grid layout based on where in the layout it's gonna be located. Where it is, row is always 0 for now, column is based on where we are in the for loop, 0, 1, 2, and 3 in this particular case. Then we say the parameters for this particular tile in terms of the width and height are a value that is actually equal to the size of the screen divided by the size of the grid. So whatever is the size of a screen, we divide by 4, and that becomes the width and height of each single tile. We set the background to red, we apply the parameters to our image tile, and we finally add this image tile to our game grid layout, which is in here the green interface or the green background. Great, so we got this far. The next thing that we want to do is this. We want to be able to use this guy, which is called image name, and apply a different image to each of our image views. To do that, I'm going to go ahead and say, instead of this red, because we obviously don't need this red, okay, instead of this red, what we're going to be doing is this. We're going to say image tile dot set image resource. Okay, now we have to apply an image resource that reads from this folder of drawable within this package and reads the correct name. So let's go ahead and just make one of those for now. I'm gonna say int resource ID. I'm gonna call it res ID. I usually do that, that's why it came to my mind. I'm gonna say res ID is basically resources dot get identifier, and the identifier that I want to use in here is the name that we have in here. Let's say img underscore 1, and then they are within drawables. They are within drawables, yes, and these are within the package name, whatever is the name of this package. So res ID is the resource that we want to apply. One more time, we got our resource ID from resources img1 within drawables and within this current package, and we applied that to be the image resource for our image tile. If we run this application now, we should be seeing 4 obviously identical images sitting next to each other. Great. All of them are the picture of the horsey. So let's go ahead and make this based on where we are in the for loop. That should be actually quite straightforward. So what I'm going to do is I'm going to say this guy, string image name, is equal to images array. The value that we want is v for now, 0, 1, 2, and 3, but later on we have to change it. Let's read it as a string. Okay. And image name is this image. Let's run. Good. So we got image 1, 2, 3, and 4. They're all sitting there the way they should be sitting. Excellent. Next thing I want to do, I want to say this row 0, 1, 2, 3, you have to do it 4 times. So basically the process of making the images on the columns, column 0, 1, 2, 3, this should happen 4 rounds. So we get this series, and then we get another series, and then so on and so forth. So I'm going to say this entire for loop should happen 4 times. I'm going to say for integer h equals 0, h equals smaller than grid size, and h plus plus, we do this. Okay, that's why I actually named them h and v. This is for horizontal and this was for vertical. So this one makes the vertical guys and this guy makes the horizontal ones. Now things are very, very easy. All I have to do is I have to say every time you're making an image view, look at h to decide what row you are. Obviously the first time h is 0, and you make all of the 4 of these guys. Then the next time h becomes 1, and you make all of the 4 of these guys, so on and so forth. All right, let's run it. There is an error, I can see it, but I want to see in the interface, and then I explain it to you. Great. They're all working. We have the images 4 by 4. But what we are missing in here is the fact that they're actually repeating the same images. And that is simply because every time the image name is based on v, which is 0, 1, 2, 3, 0, 1, 2, 3, and 0, 1, 2, 3, and 0, 1, 2, 3, 4 rounds of the same image. That's not something we want. You could write a formula here to find the value of what image number you have to read based on h and v, and that's actually quite simple. It's basically whatever value you have in the v plus h multiplied by grid size. Okay, but I don't want you to do this. It's a bit complex to understand, and there's really no value in it. What I will do is this. I will add a value on the top, integer image img number currently equals 0, and I'm going to use the img number as the value for images array, and every time that I use this, the moment I'm stepping out of my for loop, I'm saying img number plus plus. So I add 1 to the img number to make sure we go to the next one, and the next one, and the next one, and the next one. So we'll go to so many of those. Let's run the application again. We still should have one tiny problem, but we'll come back to that in a second. And my emulator, yes, it finally worked. So I've got 16 different images, just like how we expected. Actually, we didn't expect this. We were hoping to have 8 images and then 8 copies of those images, simply because this is a memory game. Right now, there is no 2 images that they are similar or identical, and this game is obviously not playable. So what we have to do is we have to make sure that we go through our images and we get half of the size of our entire grid, which in this case is 16. We get half of that, and then we get another copy of those half. So let's see how we're going to do that. All of these images are based on the image number. So I'm going to go ahead and say if image number was equal to grid size multiplied by grid size divided by 2. Where is that number coming from? If the size of grid is 4, it means the game is 4 by 4, 16. It means half of it is 8. So if image number went through 0, 1, 2, 3, 4, 5, 6, and 7, the next one, this is already 8 copies. The next one shouldn't be 8. The next one should be 0 again. 1, 2, 3, 4, 5, 6, and 7. You understand? What's happening is we go through 0 to 7 and then we go to 0 to 7 one more time. So that's very easy. I'm gonna say if as you're adding to the image number, if it did reach 8 in this case, then say image number is 0 and start counting again. So it goes from 0, 1, 2, 3, 4, 5, 6, 7. At 8, it becomes 0 and starts going up. 0, 1, 2, 3, 4, 5, 6, 7 again. Let's run this one more time. Fantastic. So now I've got horse, statue, stadium, Santa, dog, bird, woman, and beach, and again horse, statue, stadium. So 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Now the next thing we have to do, we have to actually find a way to randomize this, because right now you would always know this image is equivalent to 2 images below it, this one 2 images below it, this one 2 images below it, this one 2 images below it. So what I want to make sure is I want to make sure that I apply a randomizing method to this application or to this set of image blocks to make sure that they're random locations. To do that, to do the random locations, we're gonna need 2 things. One is we need to know what blocks we have made so far. Let's say you decided to move this block, the block of this statue, and place it here, and take the Santa and place it one above it, and take whatever was there, put it somewhere else. So we need to know what tiles we have made so far. That's one thing. We also need to know what locations are available to us. This is, for instance, the location of 0 and 0 on the grid. This is the 0 and 1. This is the 0 and 2. So we have to actually memorize all of these locations within 2 lists. So I'm gonna do that. In here, where I have, I'm here already, so let's go ahead and say list, and this new list is actually gonna hold on to image view, and I'm gonna call this one tiles array. All right, is a new list of image view, and then list. The next one is actually a location, and that's basically a 2-dimensional object. We can actually use a point for it from android.graphics. And I'm going to call this one maybe coordinates array. Coords array is a new list of point. Excellent. So I've got these two arrays that they're gonna hold on to my locations and to my tiles. The tiles part is actually quite straightforward, because the tiles part what's gonna do is every time we make one of these tiles, we're just simply gonna add it to it. We're gonna say this one, so tiles array dot add, what do you want to add? Image tile. So that's about it. So we made an image view or an image tile, we added that immediately to our tiles array, and that's pretty much all there is to it. The point system is a little bit more little bit trickier, because we are using the H and V as horizontal and vertical in here. So I have to make a new point and add it. I'm going to do that right at the very beginning, or actually it doesn't matter. I'm going to do it here. So what I'm going to say is point, and this point is a, let's call it the new location, or a new place, or new whatever that you want to call it. It doesn't really matter at this point. It just matters that we understand it is not a graphical point. It's simply a matter of holding on to our location of, let's say, 0 and 0, and then 0 and 1, and then 0 and 2. You could actually manually make this. You could say 0 0 and then 0 and 1, because the numbers aren't very difficult. You know, if it was a point system, an actual graphical point system, and one of them was, I don't know, 36 and 67, and then the other one was maybe 89 and 92, then it would become very, very difficult. But right now is not that difficult. However, I'm gonna say point, let's say this coordinates equals 2, and I'm gonna say new point of horizontal and vertical. All right, and coords array dot add this coordinate. Now there is also a way to mix all of these together. You could actually cut all of these, go up here at the very beginning. All right, say I made a new image view, I made my new point, and then when I'm making the row spec and column spec, I'm gonna say, instead of H and V, I'm gonna read this coordinate dot X, and then this coordinate dot Y. It's absolutely meaningless at this point, because this coordinates X is H, and we had written H in here, and this coordinates, you know, of Y is V, and we had written V in here. So it's basically exactly the same thing, but just in case you wanted to see it one other way, you could actually do that as well. I don't really mind either or. So I made my point in here, and I added to my coordinates array. So by the end of this for loop, the bigger outer for loop, let me write this down. I'll have an array of all tiles. This is very important, ordered from 0 to grid size by grid size, and I'll have an array of all coordinates. All right, so that's all we needed up until now to make sure that we have this situation, and we are also ready to go and start randomizing our game. Let's keep it up to here. In the next lesson, I will randomize the location of these blocks.